Hey guys, welcome back. Don't forget to send in your questions. We're doing a new topic next week, guys, factoring polynomials. Going to be covering remainder theorem, zero product theorem, all of that kind of stuff. So send in your polynomial questions, because if you get featured on the show, you could win a 19-inch TV, which is a really rad prize. We also have a lot of data and stuff that we want to give away to you guys. So send in your questions. It's so easy to enter. Just send in a question. If we feature you, you stand a chance to win. For now, we're going to take the last question of today's episode, and for 3D trigonometry, it's from Kiwi, so let's check her out.
Hi Tenfold, my name is Kiwi and I'd like help with this question. Thank you. Bye.
Okay, so this question is nice to end the show off with because it's just a plain basic 2D trigonometry. Sometimes you guys are fine with the 3D, you just need a little buffer of your 2D knowledge. So let's jump right into this question because it's got a few parts and I want to try and get through all of them. This question says, given the quadrilateral ABCD with point E connected to each vertex, that just means that it's connected to each corner of the quad. AEC is a straight line with a length of 18,54 meters. The total area of the quadrilateral is 209,6 meters squared, and angle ECB is given to us as 35,33 degrees. First thing that we have to find out is the value of EC. Okay, so if I redraw my diagram here, the only triangle that has information in it, that has EC in it, is that triangle there. We've been given that this is 118,88 degrees. This side measures 15,4, and in here we've got an angle of 35,33, and we're trying to find EC. Okay, so for me, immediately I don't love using the cosine rule just because it has so many different parts to it, and you have to remember which sides go where and which is the included angle. So I want to try and use the sine rule. So let's have a look and see if we have enough information. Okay. So the side that we're looking for is this EC, and it's opposite that angle B there. Okay, so we're going to have to try and find that angle if we want to use the sine rule. But otherwise, we're given this side as well, which is opposite that angle. So we have enough information. Since we have the third angle of the triangle as well, we can use interior angles of the triangle to find that angle B. Specifically, that angle is EBC. It's equal to 180 degrees minus 118,88 degrees minus 35,33 degrees. So let's check the calculator out with the situation. When my mouse starts behaving with me. There we go. Okay. 180 degrees minus 118,88 degrees minus 35,33. Okay, so that means that angle is 25,79 degrees. Okay, so that's this angle that we found here. Now, easy peasy, substitute into the sine rule. So we're looking for side EC. Let's get some more space here. EC over sine of that angle that we've just found is equal to the side that was given to us, which is 15,4, over the sine of its opposite angle, which was 118,88 degrees. Make EC the subject of the formula, and we multiply by sine of 25,79 degrees, all over sine of 118,88 degrees. And we stick that into our calculator. We get 15,4 multiplied by sine of 25,79, all over sine of 118,88 degrees. And that gives us 7,65. I'm going to round to 2 decimal places. Okay, simple enough, guys. So we found here that this is 7,65. We also found that that is 25,79, if I'm not mistaken. Let me double check. Is indeed. Okay, so now we're trying to find the value of AB, which is this side over here. Okay, well, we were told specifically, guys, that this line here is a straight line. So we can treat this whole big triangle as a triangle that we can work with. Okay, so here, because we have these two lengths here, we have the whole length of that side there, which is 18,54 plus 7,65, and that's AC. We also know that this here is 15,4, that's B. This here was 25,79 degrees, and this here is 35,33 degrees, and we are trying to find AB. So we have a side, an included angle, and we're trying to find the opposite side. So now we use the cosine rule, and I thought I was going to get away with not using it. Okay, so we get AB squared is equal to that whole sum there. Let me work that out so I don't have to keep typing it out. We had 18,54 plus 7,65 gives us 26,19. So that's that whole side there. So we get 26,19 squared plus 15,4 squared minus twice the product of those two numbers, 15,4, multiplied by cos of the included angle, which is 35,33 degrees. Okay, so now guys, simple substitution into our calculator. 26,19 squared plus 15,4 squared minus twice their product. Let me get this right. Multiplied by cos of 35,33 degrees. Okay, that gives us 264,98 dot dot dot. And the reason I say dot 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 is because that is AB squared. Okay, so to get AB on its own, we have to square root that whole number, which gives us an answer of 16,28, rounded off to 2 decimal places. Okay, so that's AB done. Lastly, it says determine the value of ABC. Okay, so we just found AB, which was 16,28, so we can fill that in there. Now we're trying to find this whole angle here. Well, remember we worked out the length of this side. Let me double check it. It's 26,19. So this whole side here, I'm going to cross that out so it's not confusing. It's 26,19 meters, that whole side there. Okay, so if we're looking for this angle here, it's opposite that side, and we have this angle here opposite that side, so we can use the sine rule, guys. Okay, so sine of the angle we are looking for over the opposite side, which is 26,19, is equal to sine of that other angle, which is 35,33 degrees, over the opposite side, which is 16,28. Make sine of ABC the subject of the formula. We get 26,19 multiplied by sine of 35,33 all over 16,28. Okay, so let's stick that into our calculator. We get 26,19 multiplied by sine of 35,33 all over 16,28. Okay, and we get a rather tiny number. It's 0,93 dot dot dot. But remember, that was sine of that angle. So now we need to find arc sine of this ratio that we've got here. So we say ABC is equal to arc sine of 0,93 dot dot dot. And we get, okay, second function sine, the answer we just worked out. And that gives us 68,4, let me double check here, 68,48. And that is that angle there. Okay, guys, so simple, but majority 2D, so we're just checking your ability to see that because we don't have 90 degrees, we can't use ratios and stuff. So we had to work with sine rule and cosine rule. Nice stuff, nice testing your grade 11 content. But yeah, hopefully you guys, you have enjoyed the show. I think we have a career video next. Yeah, so we're going to be checking out an architect today. He's going to show us how trigonometry is applied outside the classroom. It's a really great career video. Thank you guys for tuning in, and I'll be back after this.
So my name is Kevin Steyn. I'm a professional architect. Graduated about 7 years ago from Wits University in Johannesburg. Spent a few years overseas in Canada. I've been focused a lot on mixed-use, large-scale developments, with primary focus is more in residential. It's been a fun journey up until this point. We have the skills to really see the big picture. So, we can see areas in communities or cities that need help, or there's a gap somewhere, and that there's a need that a person has, we can go and source and help people to take that vision or take that moment of this will actually really make a big impact on the community, and we can design something that's going to create massive change to better environments, better communities, and that's invaluable. And you finish school, you go to university, you'll come out of university as almost a candidate architect, and from there you will go through a couple of years, and then you'll become an architect, like a professional architect, and then you're going to go, say, within a 10-year period, you'll do a senior architect. And within the spaces of practices, you'll go from an architect to an associate director, then to like director, and then it can scale across. It's really incredible to have this vision on like a piece of paper and then translate it into something that is this physical, built setting stone element of the world. Golden ratio is a calculation, and you can apply that to a facade of a building, like an elevation. You can give it a rhythm. Same way in music, there's a rhythm in music and it has a mathematical equation. Other areas are, I know today with the sustainable movements, the green energies, there's a lot of comfort calculations, there's a lot of thermal calculations, energy calculations, and that requires mathematical understanding. Also structurally, to understand vaults, domes, bridges, all of that has mathematical understanding. And then one can also, in a way, you can look at calculus and bridges and parabolas, and those are definitely, and also angles, just simple angles of buildings. Trig's based around angles. It's based around certain triangular geometries, whether they plan, whether they're elevation, whether when you think of the original pyramids, they were a mathematical proportion of trig. And at the same time, today with our technologies that we're using, we can actually take the trigonometry principles and apply them to certain softwares in order to generate geometrical forms that we need. Still working out angles, I'm still using sine, cos, tan, and all those different things from trig that I still use today. And maybe not as intricate, but I needed to know the basis on which to do what I do. What is happening more and more now with our technologies is you can start to input formulas, mathematical equations. You can use that mathematical coding in the software to build three-dimensional forms. And also, some of them are getting more complex, where you can go down to base coding, where you can input numbers and through graphic means, and they'll generate forms for you. Architecture is a profession about seeing and looking, not just at the physical world in which you are, but also at the needs of people. We design space and we facilitate the built environment. And in order for us to really succeed in that, is we've got to know our user client, we have to know what the end result needs to be, but we also need to be up to date with what's happening in the world and what society needs and what people need. And that's all about staying curious.
Well, guys, thank you for joining us for our first week of the live show. We've really loved having you guys around for our 2D and 3D trigonometry. Just want to emphasize some points, guys. The moment you see a 90 degree in a triangle, try and make use of your ratios. It's so much simpler than having to work out things and manipulate things. Also, as Sibusiso mentioned earlier, if you have no idea where to start with a question, look for triangles that have 3 bits of information in them, because those are most likely the starting points in your trig. But hopefully we've helped you guys. Thank you so much for sending in your questions. Please continue to do so. A lot of you guys are asking us stuff on the WhatsApp. We're loving hearing from you. Thank you so much to Liberty for sponsoring our show and our app. We really love doing this and being able to help you guys. Don't forget, guys, next week is factoring polynomials. Send in anything you have to ask about factoring polynomials. If you get featured on our show, you stand a chance to win great prizes like an 19-inch TV, some data, airtime. We really love having you on the show, guys. You are what makes this possible, so please send in your questions. We would love to hear from you. But yeah, that's all from us for now. Hopefully you guys enjoyed our content. Remember to tune in for the stuff that we have before this live show. It preps you for our topic, gets you a little bit orientated towards the maths, and we've also put it together with you in mind. So without further ado, we will see you next week. Please tune in and have a great weekend.